Alright, we're going to do a quick recap for a minute of all of our exponent laws that we've talked to up to this point. The first three involve exponents and what you do with them when you're multiplying. So we talked about when you're multiplying powers together, you add the exponents, and then if you to a power, you multiply those exponents, and then if you have a power that's on a product, then you put that exponent on each factor of the product. Now we are getting into what you do with laws 4 and 5, where you're dealing with exponents and division. Okay, and law number 4 is what we've already talked about, where you work with a quotient of powers. That is, when you're dividing two powers together. If you recall, when you divide powers, you subtract the exponents. And that's what we talked about on the other day. And then today and now we're going to talk about law 5. What happens when you have a power on a quotient? So, law number 5 then is what we are looking at here, a power of a quotient. So when we have a quotient, when we have things that are being divided by each other, and they're all raised to a power, then we raise the numerator and the denominator to that power. So if you think about a quotient being a fraction of things that are being divided, you're going to put the exponent, you're going to put the power on the top part of that fraction and the bottom part of that fraction. Of course, algebraically, we might represent that like this, where we have something like a quotient that says A divided by B, and we'll raise that to the power of X. Okay, we have a power of a quotient here. And that power, that exponent, is going to go on the numerator and the denominator. So now we will put the A to the power of X and B to the power of X. So we're going to simplify this first example here, where we have a quotient which says 1 over 2 to the third power. Right? We have a quotient, a power of a quotient here. So, in order to follow this law, in the rules of simplifying this expression, we're going to take the power and put it on the numerator, and we're also going to put it on the denominator. So it's going to say then 1 to the third power over 2 to the third power. And we will take this a step further and actually figure out what 1 to the third power is. Of course, that means 1 times 1 times 1, which is still 1. And in the bottom, we would get 8. And that's how we would simplify this first expression. Okay, next expression is going to be slightly more complex. Where we have a power, that is the exponent of 4, to quite a hefty quotient here. And we're just going to follow the rules again. Here, I do want to point out one thing. It's before we put this power on the numerator and the denominator, we're going to first look inside the parentheses and see if we can do anything in there to make our life a little easier. Okay? This comes back to thinking about the order of operations, where you always simplify inside the parentheses first. Okay? Before you do anything else with exponents, you always look inside the parentheses. So we're going to look here, and I do see one thing, perhaps you see it as well, that we could do inside the parentheses on this fraction, and that is that we could simplify the y squared over the y cubed. Okay, so I'm going to rewrite this quotient to say negative 2 on top and the 3 on the bottom. The x is still going to be up there, but y2 divided by y to the third power, y to the second divided by y to the third. We're going to subtract those exponents, and the new exponent then on the y will be a negative 1. 2 minus 3 would give us a new exponent of negative 1. Okay? Now that we've simplified inside the parentheses, we'll go ahead and put that power on the numerator and the denominator of this fraction. Okay? We're going to take this one step at a time here, although some of you may be ready to jump ahead. If I put 4 on the top, I'm going to be putting it on this entire numerator. The 4 needs to go on this entire expression, and now you're putting a power on a product, and so in just a moment, as I put the 4 on the denominator as well, we're now looking at trying to determine what to do with this 4 that's on a product. What do you do with a power that's on a product? That exponent of 4 needs to go to each factor of the product. So it's going to say negative 2 to the 4th power, x to the 4th power, and putting a 4 on what's already a negative 1 will give me y to the negative 4th. And then 3 to the 4th power on the bottom, we can write that one more time that way. But in our final step now, let's go ahead and work this out. Negative 2 to the 4th power will be positive 16. Everything else remains the same up there. In the bottom, we'll get 81. All right, let's do another one like that. Where we have a quotient that is to the power of 3. And so, according to this law, we're going to take that power and put it on the numerator and denominator. Before we do that, I've almost forgotten my own recommendation. Can we simplify anything inside the parentheses first? Well, 2 and 4 could be reduced there to be 1 over 2. Okay? You can always check that out there in those coefficients. X to the power of negative 2 divided by x to the power of 1. Because they have the same base, we can subtract their exponents there and get x to the negative 3rd power. Right? Because negative 2 minus 1 will give us an exponent of negative 3. And the y will be down there by itself once again with the 2. So now it's time to put that power on each part of the, or we can just put it on the numerator first of all, although some of you could be jumping ahead beyond this step already. I'm putting the 3 on the numerator, and I'm going to put the exponent of 3 on the denominator. But then, of course, I must put that 3 on each factor of those products. So it would be 1 to the 3rd, x to the negative 3rd, to the power of 3 in the bottom. The 2 will get a 3, and the y will also get a 3. And so our final answer will look something like this. Okay, last question. It deals with the power, a quotient of a power. Again, looking inside of the parentheses. Inside, there's a lot going on in here. Okay? And before you start to think about maybe reducing 6 over 2, first of all, work with the exponent, because in this case you'd be dividing, but before we divide, we must apply exponents when we're working even inside parentheses. Exponents must come before division. So this exponent of 2 on the top, this exponent on that product there needs to be distributed, as some of you say. And so we're going to have 6 squared times a to the 8th up there. Bottom will remain the same, and it's all still to the power of 2. Of course, 6 squared is going to give us 36. And still working inside the parentheses, before we put this exponent out here on everything inside, we need to simplify what's inside as best as we can. I'm telling you that because that will make your life easier. You don't want to put an exponent of 2 on a 36 if you can help it. So working down, 36 over 2, that can be reduced to 18 over 1, and a to the 8th divided by a to the 6th. If you think about exponent laws there with division, that would leave us with an a to the power of 2, which is still, of course, all to the power of 2 again. And now we're ready to finally put this exponent of 2 on the numerator and on the denominator. 18 squared. And then when we put this exponent of 2 on the other exponent of 2, that'll be a to the 4th. And 18 squared. I'm going to need to do this one over here. Get 324.